In this video, we're going to talk about distance measurement. So a huge part of surveying is measuring horizontal distances. And there's more to this than you think. Um, it's for the last, let's say, 30, 40 years, this has been much improved by the introduction of electronic measuring devices. But before that, things had to be done in ways that we'll learn about, but in a way that didn't allow for as much precision as we can have nowadays. So that meant that looking exactly into how we measure electronic distances was a huge area of surveying, and it still is. So, by the way, if you think about how measurements were done even before officially coming up with the metric system, or officially coming up even with the imperial system or the customary system, things were very often measured with body parts. So that does not allow for a lot of precision, but think about it. The feet, or when the foot from the customary system that we use here, actually that's exactly where it comes from, right? The length of a foot. Now, which foot, I don't know, but at some point someone said this foot and then they standardized it. So we're going to talk about that. So other measurements that used to be done back then were cubits and fathoms and whatnot. It was more stuff like the distance between my middle finger and my elbow, or between or the span of my arms from tip of my middle finger in my right hand to the tip of my middle finger in my left hand, and that kind of stuff. So it's kind of crazy to think that that's how that was the official way of measuring things back then. However, there were other methods that slowly started to come about that became more standardized, because you realize that, again, we are all, as humans, some are taller, bigger, smaller, so necessarily using body parts is not the best way to go about it. However, it's one thing that sort of made sense. Now, in this country, we use the customary system. Every country in the world has adopted the metric system except for Burma, Liberia, and the United States. So that makes life a little more complicated, but not so much so. The different surveys will be in different units. What's important is just realizing what system of units you are in. So something that you probably haven't given much thought to, and we really take this for granted, is that when we talk about a foot, or we talk about a meter, how do we know that a meter is a meter? Where did the meter even come from? The metric system was established in the, I think, like 1700s in France. It's not quite that old. Who came up with this meter? And even the foot. Whose foot? How was it standardized? All of that kind of stuff. There's a science to standards. And actually, it's sort of a lot more complex than you'd imagine. So officially, a meter is 1 over 10 millionth, or 1 millionth, of the distance from the equator to the North Pole along the surface of the Earth, and a foot is 1 over 3.280840 meters. So we have relationship between feet and meters and other units. So whatever units you're working in, you can always convert. That is not a problem. Unit conversions, however, again, important to know what system you're using. So now, through the years, they've come up with different ways to determine what a meter is. And although we have this like 1 over 10 millionth, things like temperature matters. There's so many things that are accounted for. So there are institutions here in the United States that take care of making sure that the meter stays a meter. And it's only a meter if you use the official meter bar, which is kept in a special place at special conditions, humidity-wise and temperature-wise, because we know that materials expand and contract with different, with varying temperatures. So even though it would be a very small difference, it's a difference nonetheless. So there are standards that have been built that are kind of checked regularly, and you can check your own measurements against this standard. And Yes, exactly. It's insanely important that we keep the original meter a meter. Otherwise, how do we know that we're measuring correctly? And little tiny differences make a huge difference on the long run. So if your meter stick is actually 1.01 meters, if you're about to measure an entire, you know, mile or more, then slowly it starts to add up. So anyway, just things to think about, how important it is to know what you're measuring. Now let's talk about different methods that are used for measuring distance. Here are some of the basic ones and they kind of go in order from basic to more complex. Pacing, odometer readings, stadia, taping, electronic distance measuring devices, and global positioning system. We're going to talk about each one of these in here. So let's talk about pacing. You should have done a pacing lab, and if you haven't done so, you will. So it's important to know what your pace is. So we all walk, we have a certain, leg length and a certain stride length. And if you can do some easy calculations. If it's 100 feet from here to here, how many paces do I take from here to there? And then you make some easy math and you determine what your pace is. So this is very useful, practical, cheap, easy. It's not very precise, but what pacing is very useful for is to give you a ballpark figure. So if you need to measure something with a lot of precision, this is not the method, but this is a method to use if you don't have any fancy equipment with you, or maybe you just want to know roughly how much the area of this, say, soccer field is. Also, let's say that you have some fancy equipment and it's giving you a reading and it's not sounding quite right. You're like, this can't be right. That does not look like 120 feet, nowhere near. So what you can do is you can pace it, and if you know your pace, you multiply it times the number of steps you took, and then you can say, well, no, according to my pacing, this is only 90. So it's more likely that the electronic distance measuring device is just completely off, running out of batteries, or miscalibrated, than that you are, for whatever reason, walking wrong or something. So it's a great way to give you a preliminary idea of what this measurement is. So the precision is 1/50 to 1/200, depending on the ground condition. Obviously, if you're walking through muddy areas or high grass or things that aren't actually flat, areas that aren't flat, then you might have a little bit of a problem. Let's talk about the odometer. You may have heard this before. You use one all the time in a way. This is something that your car has. So an odometer is a device attached to a wheel which counts revolutions. So this device knows, kind of like with pacing, it knows rather than for every step I am advancing this many feet, this tells you for every revolution how many feet or meters or whatever units you're using are we advancing. So it translates this number to a distance. So there used to be this kind of bicycle wheel looking thing that you would just drag around with you, and it would just be counting its own revolutions, and at the end it would calculate the distance traveled in your car. That's what it does. So again, it's good for preliminary surveys. It's not too much more it's not more precise than pacing really, but what it does is it's great for when you're doing longer distances and pacing. The one risk with pacing is that you're counting in your head that you might actually lose track. One thing you can use with pacing is a pedometer, which will count your steps. But if you don't have that, and also if you, depending on the terrain, sometimes an odometer is just a better way to do it. But of course, the ground has to be somewhat smooth. Okay, so the next thing is tachymetry. Tachymetry is really a word that means swift measurement, which, if you think about it, means that every measurement we do swiftly is tachymetry. But now in surveying, there's a very specific, very specific way of measuring things considered tachymetry. And there's a couple ways to do it. One is with a subtense bar, and another one is stadia. So subtense bar is actually obsolete, but it was done using a theodolite. Now I know that you may not know what a theodolite is at this point. We're going to talk about them. We're going to talk about theodolites plenty in the future, but just know that it's something that has this scope, and you can sight things, and it'll let you make readings. And what you have to do is, that's the subtense bar, not the theodolite, but you would be looking from the point of view of where we're looking at the picture from, and you would have, like your scope would have these lines, and you would be able to calculate. So you would be here, and you can calculate this angle and this distance from here to here. You know it's 2 meters. So with some basic trig, you could figure out how far this thing was. So that was one way of doing it, but we're not going to look into that too much. We're actually going to talk a lot more about something called stadia. Now, stadia is levels, and theodolite scopes have these crosshairs. The top and the bottom crosshairs are called the stadia hairs, and what it is used is you're going to have this either a level, an automatic level, or a theodolite, and you're going to have someone standing on the other side of the field, marking wherever you want to measure with this rod that has either marks in meters or in feet or something, some unit, and then you're going to see through the crosshairs and try to calculate the distance with a little bit of math as well. So the way this is designed is so that if you see a 1 foot difference between the top crosshair and the bottom crosshair, that means that you are 100 feet from the thing you're measuring. If you have 2 between the top crosshair and the bottom crosshair, this means it's 200 feet, so on and so forth. So you just multiply this number times 100, and it's a lot more precise than pacing or the odometer reading. You can also use it to calculate heights. So if you know that you are 2 feet, like this is kind of like an arm's length distance from your apparatus, and you're going to see the top of the tree and the bottom of the tree, and there is a 6-inch difference between these, and it's 100 feet from you, then you can calculate how tall the tree is. And this tree is actually, so you have 100 over 2 times 6, and it gives you 300 inches or 25 feet. So this tree is 25 feet tall. We're going to work more on this later. We're going to talk more about this later, and you're also going to do it in lab. Okay, so we're going to talk about taping and chaining in the next video.